Okay, folks, can you hear me? Yes? Okay. So I'm John Mesa. I work at Esri, as it's called now. The acoustics up here are really bad, so you can't tell you can hear anything. Okay, I work at Esri. I'm the team lead for the performance engineering team. I happen to work on a lot of different products. And what I'm going to show you are two main things. I'm going to show you how our products hook into a Hadoop cluster to allow you to do spatial analysis on the data, the spatial data within your cluster. Then I'm going to show you also one of our products, and it's our new product. It's ArcGIS Pro, which has a brand new rendering engine. I'm going to show you rendering from a data center. So those are the two things. So I'm going to start off. How many of you are familiar with ArcGIS products? Okay, so we've been in the GIS business for a very long time. We started in 1969, and we are the major market holder in that industry. So we do a lot of business. We are heavily invested in and are big. What we're famous for is spatial analysis. And there's a lot to it when you talk about spatial analysis. With spatial analysis, you need spatial data. So those two big things, that's a big part of GIS. Do you hear any echo? Or does it sound good to you? Okay, because there's an incredible echo here too. It's very bad. So I'm going to assume you're all very happy with the sound. So we have multiple products. We have a desktop product, which we started out as a workstation. We had a workstation application on Linux machines or Unix machines. That was a long time ago. Now the GIS industry has exploded. We have the Windows applications that do the spatial analysis, and that's called ArcGIS for desktop, or our desktop product suite. The big product there is ArcMap, and that is where you publish maps, you do cartography, you also do spatial analysis on your data. And remember, I'm not talking just about spatial data, but you can combine the spatial data you have or you use online from us with your own business data. Okay, so that's one. We also have a web tier. We have web server technology where you serve out spatial data, whether it's vector, raster, LiDAR. We have server technology that we host in a data center or you have on-premise, and you serve out your own data internally or publicly. We also have a vast array of APIs and runtimes for you to create your own products, enhance your products, tie in functionality and customize our products, create browser products, put maps into your browser apps, put maps and functionality into your mobile apps. We have all of that. So recently, in development, in our geodatabase team or geodata management team, we've added the capability to hook in to a Hadoop cluster. So let me just start to show you. From our ArcGIS Online, there's a variety of capabilities here. So let me just show you. There's our website, and then for ArcGIS Online, it serves out spatial data, but not only spatial data, it provides maps, pre-made maps that you can use. You can use in your apps, you can reference online. It also has these complete different types of storyboards or stories that you can develop. And here's an example. This is an example of the landslide that happened last year in Washington State, or this year. I forgot when. But this is a very simple map, but it gets to the point. It serves out spatial data, and if you notice there's raster data in the background, it's connected with, or it's overlaid with some parcel data. And then it has some point data, and that shows you where each parcel was that was impacted by that landslide. And each one of these dots here is where one of these individuals, where they were located when they were injured or when they were killed during that landslide. And what this does very quickly is these are two layers. They're always geo-referenced, and this shows you the before the landslide. And you can see there's a river there, and where all the lots are. And then the after. And you can see where that graphically shows you right where that landslide went. It just went right through there. Here we can zoom in. And you can see where there's nice green trees, forest. Right after, there's nothing. There's nothing. How could you ever expect anyone to survive that? And then you can look at the extent of that. Before and after. So that's just one example. There's another example, and this is of our web technology. And here's a place where I can make a map. And so I just get this base map data, and this is really good to start to tie into my next story. Our servers serve out a variety of spatial data. Not only can you host your own data in a geodatabase, that's really an Oracle, Postgres, or SQL Server database that has your spatial data in it, along with all your business data. Or you can host your data from a web server. And that's just what we do here, and we're connecting to it. Anyone can connect to it. And this is a base map, just very simple, some political boundary data. And here, let's overlay this with something. Well, first, let me zoom in. Okay, I'm going to zoom into this area. Let's zoom way in. Okay, and let's kind of look where we're at. Okay, there we are. Now I'm going to go over here and add. I'm going to add some layers. Let me see. No, I'm not going to add that. Search, browse. Let's see what's available. And these are the layers that I can add. Let's go look. Do I see anything here? No. Okay, I see something. I'm going to add this data here. World Traffic Service. As a layer. Okay, close. There it is. I just overlaid some traffic data on top of the base map. So actually these are both services that we're providing. Okay, this is some of our technology that we have available. And as you can see, where are we located? We're located like right here, correct? So traffic's not too bad right now. If you wait in an hour or two, these are all going to be reds. But anyways, I digress. So that's an example of our web services. That's just one tier of our technology. Now, what we also, as I've told you, are starting to do is we use spatial data in a geodatabase. That's just putting your data in a certain format into your Oracle database, SQL Server, Postgres databases. That's a geodatabase. So our applications consume that data. So your applications can also. You can use our APIs to put that map into your browser application, onto your mobile app. This can all go right onto your application. We're consuming data. Not only that, but our Windows-based products used for spatial analysis, map authoring, publishing, cartography, they consume it also. And now, what they do, and here's another example, now what they do is this. Let me show you here. And this is a little difficult. Oh, okay. This is, and I'm VPNing back into my machines back in Redlands. And this is a look at my data that's held in my Hadoop cluster. So let me tell you a little bit about this data. Those web servers I showed you earlier, just a few minutes ago, serving out spatial data. We have a lot of servers out there. We have a lot of services serving out a variety of spatial data. Big part of that were those base maps, that political boundary map you have in the background. So we have about 10 or 15 base map layers that we serve out that are extremely popular. And what we do, as many companies do, we have to do the web log analysis on the logs pumped out by those services. We are a little behind the game on this because a lot of the web log analysis has been done in SQL Server. But there come to a point where when your queries take 4 to 12 hours, you need to start to look for another solution. Fortunately, there's Hadoop, there's HDFS, there's Hive, there's Impala, there's Apache. There's all those tools that are available to take care of that. So we've adopted it. This is analysis, or this is a picture of our weblogs for one day in September. We generate 1.5 to 2 terabytes of weblog data a week. So you can see we are just growing and growing and growing. We got to go through that stuff very quickly. So each row in that weblog is for one HTTP request down to our services. That request requests a specific tile from that service. Behind each service, we build caches, multi-level caches, 20 deep, so that you can zoom in and out. You zoom in and out, and the browser or your app is working with a tile, and it's zooming in and out. When it gets to a threshold, it works on another tile and another one. So each one of those requests down to those services is put into a weblog, along with a bunch of other stuff. What this shows is one day for those services at one scale. That's scale 10. That's that mid scale. And so it's pumping out these tiles nonstop. It's just going crazy. What you see here, red, is where there's a lot of requests. There's a lot of requests for tiles. Green, there's less requests. There's a couple of things that we see here. We visualize our big data because that's what we give now to big data. We give the ability to visualize on a map your big data. Or not only a map, there's other ways to visualize it. Just as importantly, or more importantly, you can now do spatial analysis on all that data within there. So here, there's a couple things that I'll point out. Right here, you can see that is, well here, let me zoom out. That is Let me zoom out a little more. That is lat long 0, 0. Those show applications which are poorly designed in that they either start at 0, 0, or they, for some reason, they go to 0, 0. But you can see they all go back to the continental U.S. These are not the individuals panning back to the continental U.S. because you can see they're very straight lines. Humans don't work in very straight lines. These are the automated processes going back to the continental U.S. Okay, there's something else that is very interesting. You can see here, these are automated processes. Now, I don't know why. Maybe there was a problem here, but you can see that chunk there. This is how scraping looks. Scraping is when you have organizations, individuals that come and harvest the tiles that you've already created, because essentially they're just getting a tile, a raster image that you pushed up to their browser. They're getting it and they push it down onto their servers. That's illegal. But we watch for that. One of the ways we watch for it is we have an ongoing video of our services and their usage, and we can see scraping. About a year ago or 6 months ago, we saw scraping in an industrial scale for a certain part of the world. Every day we'd go in and we'd cut off some IP addresses for those scraping processes. But the next day they'd switch their IP and boom, you'd see they just pick up where they left off the day before. Scraping continued. So there's some big scraping projects. So that's one thing I wanted to show you. But now let me show you our newest product. And I'm going to go over here. And this is a product that's going to be, it's in pre-release right now. And it should go final, I think, in December, next month. People have been working really hard on it. This is not going to take the place of ArcMap, the queen of our product suite. It's where all the spatial analysis, map publishing, cartography is done. It's not going to take the place, but it's going to sit alongside of that product. And ArcMap, the older, or let me just say the more mature product, its rendering pipeline was built on Windows GDI Plus, which is not something you would think of as contemporary. But yet there's a lot of functionality built around that guy, a ton of functionality. So now we built Pro, this guy right here, and this guy here, he's built from the ground up using a DirectX or OpenGL rendering pipeline. It's fast, it's fluid, you can do all kinds of spatial analytics on it. It's just sweet. It's sweet to look at. You can do selections. You can get characteristics. You can do all kinds of stuff. This is a GIS tool. This in it is an industrial strength GIS tool. So it's not for the meek and mild. It's made for people who really need GIS. So there you go. There's that. But we have a really big concern. Here we build this application. It renders great, provides a lot of functionality. It's a high-end rendering graphics engine. Okay, so. But a lot of our current users are virtualizing our products. How well does this work in a virtualized environment? And forgive my laptop, it doesn't even have a discrete GPU, or it'd be cranking right now. It has one of those integrated GPUs. Okay, so virtualization. How do we put this in a virtualized environment? We've tried this in a virtualized environment. It doesn't do that great. But you know what? We've been working heavily with NVIDIA. NVIDIA now has come out with shareable GPU cards, the grid K1 and K2 cards that are designed to be used in virtualized environments. That's where the hypervisor hooks up with all the VMs, and it will share out the GPUs. The K1 card has 4 GPUs, K2 card has 2 high-end GPUs. And the hypervisors, Hyper-V, Zen Desktop, as well as Zen App, and VMware Horizon View all have modified their hypervisors and functionality in there to work with these shareable GPUs. So you may wonder, wow, give me a look. Okay, ouch, we better, let me try to connect. And I'm going to connect to you to show you that experience. And this experience is, trust me on this, 1, 2, 3, 4. This will take a second. What? Hang on a second. Okay, and there we go. You know, this was hooked up. You guys probably saw it cut out behind me here. Okay, give this a second. And so this is showing, this is from the NVIDIA Tri-Grid workspaces. So this is a cloud-based VDI solution, and this is where NVIDIA puts GPU, shareable GPU capability behind every VM. And what I showed you earlier, the smooth animation provided by our DirectX rendering pipeline, well, that is a challenge to deliver in virtualized environments. But here it is, and let's just show you real quick, like. Well, here I took you way out in the middle of nowhere. Let's go back. So this is delivered from a data center, and this is in a VM, a VDI solution. This is desktop as a solution. It's providing a GPU empowered VM. High right now. The stuttering that you're seeing here is only because of the network connection. If I had a little better network connection, this would be smooth. But here, let me try to get you some of that. And you can see. And so here, I'm showing from the cloud, from their data center, hooked up with their grid cards. This VM is providing a high-end user experience. In this tri-grid workspace, Pro will be put up there so you can demo along with other graphics applications like AutoCAD as well as SolidWorks. And here, and I'll show you a couple other pieces of software that are on here. Yeah, so you have SolidWorks, not so that I just show you our software, but let me show you some other software. This is what's capable now from the cloud in delivering desktop as a service. Graphics is no longer a challenge. It's doable. Okay, and you guys, I think that is it. I showed you a bunch of stuff here in like 20, 25 minutes. And if you have any questions, let me know. There you go.